Welcome back, and now we will discuss what is the regression, and the special type of regression is the linear regression. The concept behind the linear regression, how linear regression being used. Okay, so first of all, supervised machine learning. In the supervised machine learning, machine learn under the guidance as cool as teacher guided and teaches by feeding them labeled data. So teacher in this case is training data, right? And there are the different type of supervised learning in the machine learning. We can say the two types of supervised learning. One is the regression and another one is the classification. So first come to the regression. It is a type of supervised machine learning and it is used to predict the relationship between dependent variable and one and more independent variables. And you can say a relationship between dependent variable is target and independent variables are the predictor. So this technique is used for forecasting time series modeling and finding the causal effect relationship between the variables. For example, relationship between rash driving and the number of road accidents by a driver is best studied through the regression. So basically the major uses of regression analysis are determining the strength of predictors, independent variables, and forecasting an effect and trained forecasting. Okay, now we will see what are the types of regressions. There are the different type of regression, like you can say we have linear regression, we have logistic regression, we have polynomial regression, and we have stepwise regression and rigid regression, lasso regression, and elastic net regression. So we will see one by one. First we will see the linear regression. What is the linear regression? Linear regression is probably the simplest approach for statistical learning. It is a good starting point for more advanced approaches. In fact, many fancy statistical learning techniques can be seen as an extension of linear regression. Therefore, understanding the simple model will build a good base before moving into the more complex approaches. And you can say we can define the linear regression like this. You can see here the diagram. Linear regression establishes a relationship between dependent variable. What is the dependent variable? Here y. And one and more independent variables x. Using a base fit straight line. We want to fit the base line. Or we can say this line is also known as regression line. So here the output is a continuous number or a discrete value. And what we are trying to find is, a base fit line, and we evaluate the model through the mean square error. And the most important, the difference between the simple linear regression and multiple linear regression is that multiple linear regression has more than one independent variables, whereas simple linear regression has only one independent variable. Like here, if you have only one x, then you can say this is a simple linear regression. And when you have more than one x, more than one independent variables, then you can call it multiple linear regression. Okay. Now question comes to our mind is how to obtain the base fit line. Basically, this base fit line can be easily accomplished by the least square method. Like whatever the error method you are taking, like mean square error method or least square error method. It is most commonly method used for fitting a regression line. I'll show you, like first we will see the equation for the linear regression. Let's assume we only have one variable and one target. Like we have only the simple linear regression. It can be expressed in the form of this equation y is equal to ax plus b. This is the equation for the linear model with one variable and one target. Here what is the variable? Variable is x and the target is y. And here b is a constant, or you can call it the bias or intercept of the line. And here a is a coefficient or weight. And x you already know it is a predictor or independent variable, and y is predicted or dependent variable. So in this equation, A and B are the coefficients. And these coefficients are what we need in order to make the predictions with our model. So like when we are working with the linear regression, our main goal is to find the base fit line. That means the error between the predicted values and the actual values should be minimized. So our base fit line will have the least error. The different values for the bias or the coefficient of the line given as a different line of the regression. What we will do, we have x value and we need to predict the y value. So we will put the different values for A and B. When you provide the different values for A and B, it will give the different line. So what we need to do, we need to calculate the base values for A and B to find the base fit line. So to calculate this, we use error, or sometimes we call it the cost function. How we will calculate the error? Error calculated using predicted value minus true value. Or you can use this formula, minimize a predicted value minus actual value and then square and divide by n. Mean square. This is the simple error, but generally we are using the square error. Why we are using the square error? Because the prediction can be either above or below the true values. So resulting in a negative or positive difference respectively. If it is the above, then we will get the positive difference. If it is below, then we will get the negative difference. If we didn't square the errors, the sum of the errors could decrease because the negative differences and not because the model is a good fit. So also square the errors penalizes the large differences, and so minimize the square errors guarantees a better model. So we can say we have linear relationship between independent variable and dependent variable. Now the question comes to mind is how we calculate A and B values. So the gradient descent. We will use the gradient descent to update A and values in order to reduce the cost function. And achieving the base fit line, the model uses gradient descent. The idea is to start with a random A and B values. Initially, we will take the random values for A and B and then iteratively update the values and reaching to the minimum cost. And when our cost is minimum, we will finalize A and B value. So you can see from this diagram also, we have independent variable x and we have dependent variable y, and these are the red are the data points. And these are the data points, and we just want to predict, like if data point value is this first red, then our dependent variable value should be like at this range. So this is the actual values we know. And when we prepare our model, this is the base fit line, or you can say line of the regression. Like when this value x corresponding to this value, we are getting the y value. Like this value touches to this line and you are getting the y value. So we just want to minimize this difference. Like these points should lies on this line. Maximum point should lies on this line. Then our error should be minimum. So this is the basic concept of linear regression. In the next lecture, we will see the implementation of the linear regression.